x into this differential equation, then the slope at this point is going to be -1. So we're going to draw a little line segment that has a slope of -1 right at 0, 0. Okay, maybe let's try, actually we can go ahead and fill in the points, the slope curves at all of the other vertical points along this line. So at 0, 0, it has a slope of -1. At 0, 1, it has a slope of -1. It's not changing. At 0, 2, 0, 3, obviously it's a sketch, so it's not going to be perfect. And then keep going. So everywhere along that vertical, all of those points are going to have the same slope. Okay, now let's look at what it is when our x-coordinate is 1. So if we plug that in, we have 1 minus 1, or 0. So at 1, 0, the slope is 0. The slope, a line that has a slope of 0 is just a horizontal line. So now we know that every point along this vertical is going to have a slope of 0. Let's find what the slope is when x is 2. Okay. So 2 minus 1, the slope at all of these points is going to be 1. So a line segment that has a slope of 1 might look like this. Okay. And now let's find the slope when x is -1. So -1 minus 1 is -2. So a line segment with a slope of -2 is going to be something like that, a little steeper than the ones here. So 2, 2. Again, this is a rough sketch. It's not going to be perfect. And lastly, dy over dx when the x-coordinate is -2. -2 minus 1. So the slope of these little line segments along this last vertical have to all have a slope of -3. So now it's going to be even steeper. Okay. So here is my slope field for this differential equation. That's just the first part of this problem. It also asks us to sketch the solution curve through the point -1, 1. The solution curve through this point, I tend to think of it as the particular solution based on this constraint. So in order to draw we're going to sketch what the original function looks like that goes through this point. So if we start at the point -1, 1, that's right here, where I drew that little dot. And like I said, this is just a sketch, so your sketch might look slightly different than mine, but the way we draw the curve is you're going to take your pencil and you're going to follow along. You know that the original function has to have a slope of, -2 right here. So you're going to draw a line tangent to that little line segment and follow it until you get to the next point that you feel matches it. You're trying to trace along the tangent lines, basically. So now, because I'm here, my slope of the tangent line to the curve at this point is -1. So now I'm going to kind of follow a line that has a slope of -1. Then when I get here, it has a slope of 0, so it looks like I might be hitting a minimum or something right there. And then follow that, and then when I get here, it has to have a slope that matches, the tangent line has to have a slope that matches the slope of this little tangent line, this little line segment. Okay, and then we can continue on this side. Might look something like that. Like I said, your sketch might not look identical to mine. Like this curve might be below the line segment. It just depends on how you drew it. Okay, so there's my solution curve that goes through the point -1, 1. Okay, let's go ahead and flip it. Number 2 says to do the same thing. First, we're going to draw a slope field for the differential equation dy over dx equals x minus y. Notice this time the slope of each little line segment is going to change when x and y change. So our slope curve is not going to be like the same along the verticals this time because it depends on both the x and the y coordinate. Okay, so we'll do that first and then we'll draw the solution curve through that point. So let's just pick a few points. I like to start at 0, 0 typically. So at the point 0, 0, if we plug those x and y values into the differential equation, 0 minus 0, I know my little tangent line or my line segment at the point 0, 0 has to have a slope of 0. Okay. Let's say maybe at 1, 0. Now my x coordinate is 1 minus my y coordinate, which is 0. So 1 minus 0 equals 1. So at the point 1, 0, I have to have a line segment with a slope of 1. Okay. Then I'm just going to draw a vertical bar. Imagine I keep putting dy over dx on the left-hand side. So find the derivative at the point maybe 2, 0. So 2 minus 0 is 2. So it has a slope of 2, just a sketch, like I said. Maybe at -2, 0. So -2 minus 0 equals -2. So the slope at this point is -2. At -1, 0, it's -1 minus 0, or -1, so a little less steep. Might look something like that. Sorry, this one should just be a horizontal line. Okay. Sometimes the solution, the slope field does take a little bit of time to draw. Some slope fields are quicker to draw than others. For this one, you kind of do need to go and check what the slope is going to be at each of these points. For the sake of time, we'll do one more together and then I'll kind of fill in what the rest of it is going to look like. Okay, so maybe let's try a random point, maybe at 1, 2. So at 1, 2, based on the differential equation, if we plug 1 and 2 in, it'll be 1 minus 2, or -1. So at the point 1, 2, we have to draw a line segment that has a slope of -1. So it looks like this. Okay, all right, so there's one more that we'll do together, and then I'll kind of fill in what the rest of it is going to look like.